So in this video, we want to focus on graphing logarithmic functions and their transformations. As well. So we're going to start off with us. Graphing a basic logarithmic function. Our instructions are to first determine the domain of the function and then afterwards sketch its graph. So let's work on finding the domain first. So remember, anytime you have a logarithmic function, its argument has to always be positive. So the argument in this case is x. So we're going to say the restriction on our domain is that the argument has to be positive, so x has to be greater than 0. And there's nothing to solve there. It's already solved for us, so x is greater than 0. So we can say our domain conclusively is equal to 0 to infinity, and we're going to put a parenthesis around the 0 and a parenthesis around the infinity. So that means everything to the right of 0, not including 0 though. So that's our domain. Once I have the domain, now I'm going to begin with my graph sketching. So first I'm going to put down an x-axis and a y-axis. Here's my y-axis. Here's my x-axis. So remember, you always start off with a vertical asymptote. We'll make that in purple. And that's going to occur at x equals 0. So I'm going to put this here at x equals 0. It's my vertical asymptote. That dotted purple line there. Then we're going to put down 2 key points. So for the basic logarithmic function, you're going to have 2 key points. You're going to have a x-intercept, which is at 1, 0. And you're going to also have an additional point at a comma 1. A comma 1. Now the question is, what is a here? Well, a is base 3, so we're going to have I'm going to get rid of this a. I'm going to write 3 comma 1. So I'm going to plot those 2 points, 1, 0, and 1, 2, 3, 1. So here's 1, 0, here's 3, 1. And you just connect those points, and the graph logarithms go up very slowly as you go to the right. They continue forever to the right. As you continue to the left, they get close to the vertical asymptote and they go downwards. So I'm going to label these 1, 0 and 3, 1. I want you to label those 2 key points. So the x-intercept and the additional point. Yeah, so this is y equals log base 3 of x. Okay. Now this didn't have any transformations. We'll do some later that have some transformations. Okay, here we go, number 2. So the next one is y equals minus log of x. Minus log of x. Now be aware that this one doesn't have a base on it, right? Doesn't have a base, so you can rewrite this as y equals minus log base 10. Remember, when you don't see a base, it's understood to be a base of 10. So I'll start with my domain, finding my domain. Let me write restrictions on domain. What is the restriction on the domain here? Well, your argument, which is in green here, x, has to always be positive. So there's nothing to solve there. We don't have to do any solving. We just know x has to be positive, so we can write the domain is going to be everything to the right of 0. So we write 0 to infinity. We put parentheses around the 0, around the infinity. It means it doesn't include 0. It doesn't include infinity. Okay, 0 to infinity with the parentheses on each side. That's the first step, is finding the domain. The next thing to do, now notice that log base 10 of x is the parent. So we want to talk about the parent first. The parent. That's y equals log base 10 of x. And what we're going to do, we're going to start by graphing the parent, and then we'll do this minus out in front of the house. You see that blue minus sign? That's going to be a reflection we'll do. That's a reflection about the x-axis, actually. If you remember your different transformations back from Unit 1. Or Unit 2, that was Unit 2 when we did the transformations. So let's start by graphing the parent here. For the parent, we're going to have a vertical asymptote. The vertical asymptote will be at, remember, x equals 0. It's always there for the parents. And you'll have additional points. The x-intercept, which will be at what? 1, 0. Always 1, 0, the x-intercept for a logarithmic, basic logarithmic function. And then you have a one more point. So I shouldn't have called that additional points. I'll call this additional point here. So remember, the additional point after the x-intercept is going to be a comma 1. But wait a second, what is a here? A is the base, right? It's base 10, so we're going to have 10 comma 1. So I graph this out carefully enough. If I can. X-axis and y-axis. I'm going to go, let's see, I'll count like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative. All right, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down here, negative 1, 2, negative 3, negative 4, negative 5, negative 6, 7, 8, and negative 10. So I'm going to put down my vertical asymptote purple. Let's make it purple. It's going to be right here. Where the y-axis is. That's x equals 0. That's the line x equals 0. And then we're going to put down my x-intercept at 1, 0. And then at 10, 1. And we're going to connect these 2 points. And this line, this curve is going to slowly rise, very slowly. It continues going up forever, but very slowly. And as you go to the left, it goes down towards the vertical asymptote. So plotting these points, I'm going to have 1, comma 0, 10, comma 1. Now, that is not the final graph, right? The final graph has a minus out in front of the house. So we're going to look at the transformation. Which is y equals negative log base 10 of x. So what does that negative out front of the house do? That's going to reflect everything about reflection about the x-axis. So if I reflect everything about the x-axis, the vertical asymptote doesn't change. It's still the same. Still at x equals 0. But you're going to multiply your y values by negative 1. So the x-intercept doesn't change. So I'll call these additional points. Additional points. See you, Dr. Brown. Additional points. So the x-intercept, you're basically going to multiply all the y values by -1, so you're going to get 1, 0. That doesn't change. But the other point, 10, 1 becomes 10, -1, right? You just multiply the y value by -1 there. So this point hasn't changed, but the other point, 10, 1, is going to flip upside down here to 10, -1. So you're going to connect these two blue points. And rather than going up forever as you go to the right, it's going to go down forever as you go to the right, very slowly. And as you move to the left, rather than going down to a negative infinity, you're going to go up to positive infinity. So the blue graph is our graph here. Y equals negative log base 10 of x. So that point there, I'm going to make 1, 0, and the other point here is 10, -1 in blue. So the blue graph is our final graph. It's a transformation of the parent. So it's an upside down logarithmic function, basically. Okay, let's do a number 3. So here we have y equals log base 5 of negative x. Now this itself is not a parent function. It's not an ordinary logarithmic function. It's going to be a reflection about the y-axis because that negative that's inside of the argument. But before we do anything, let's find the domain here. So to find the domain, let's call this restriction on the domain. You're going to take your argument here, which is negative x, and you're going to say it's greater than 0. But to solve that, you have to divide both sides by -1. And when you divide the left side by -1, it's just x. Divide the right side by -1, it's 0. But when you divide both sides of an inequality by a negative, it changes the direction of the inequality. So you get x is less than 0. So your domain here, if you think about that, your domain, it's everything to the left of 0. So that'd be negative infinity to 0, not including 0. So everything to the left of 0. So you can imagine your graph is going to be on the left side of the vertical asymptote rather than the right side like in the past ones. Your final graph. Okay, so we want to graph the parent first, and then we'll reflect the parent about the y-axis because of that negative inside of the house. So the parent is going to be y equals log base 5 of x. So you have a vertical asymptote. Always at x equals 0. You have a x-intercept. Always at 1, 0. And then you also have the additional point. Which is going to be at a, 1. But wait, what's a? A is 5, right? We're talking about log base 5, so 5, 1. So if I graph this out, leave myself enough space, hopefully. It's not writing. There it goes. I have my vertical asymptote from my parent down here. It's the y-axis. X equals 0 is the y-axis. I have an x-intercept at 1, 0. And I have an additional point at 5, comma 1, 1, 2, 3, 4, 5, comma 1. And, okay, so that should have been a purple vertical asymptote. It's not part of my graph, the vertical asymptote. My graph just heads in that direction. So my graph is going to, the 2 points are going to connect here. It's going to go up slowly forever. So I got 5, comma 1, and I got 1, comma 0. And then as I go to the left, it's going to approach the vertical asymptote and go downwards. Okay, so that's y equals log base 5 of x. Now what happens when I look at the transformation? Y equals log base 5 of negative x. Well, that negative inside of the house, that's going to be a reflection about the y-axis. So the vertical asymptote doesn't change. We're just flipping everything about the y-axis. The vertical asymptote still stays in the same position at x equals 0. But the points are going to flip. Basically, we're going to multiply the x values by -1. When we reflect everything about the y-axis, everything on the x gets multiplied by -1. So the x-intercept gets multiplied. The x-coordinate gets -1, so you get -1, 0. And the additional point there, 5, 1, you multiply the x value by -1, you get -5, 1. You got 1, 2, 3, 4, 5. So let's see, I'm plotting that down. I got -1, 0 is right here, and -5, 1 is right here. So yeah, everything's going the opposite direction now about the y-axis. So you're going to connect these 2 points, and as you go to the left now, the graph's going to go off to positive infinity, and as you go to the right, the graph's going to go down towards the vertical asymptote. So this is labeling these points, -5, 1, -1, 0, and this is the graph of y equals log base 5 of -x here, the blue. All right, so that's a logarithmic function that's been reflected about the y-axis. All right, I guess I'll do one more transformation. I'm not doing too many transformations. I assume you know transformations already from previous. So we're not going to focus a whole lot on transformations, but I just want you to get the feel for it. Get back into doing transformations again. Okay, so here we have a logarithmic function. It's a log base e, right? Y, let me write it out. It says y equals log base e, right? Natural log is log base e of x minus 1 inside of the house, and then a -2 outside of the house. So basically you're going to start off with the natural log, the log base e function. You're going to shift it right 1 and then shift it down 2. But before we do any of that, let's look at the domain. Restrictions on the domain. So what you're going to do, you're going to take your argument, which is x minus 1, and you're going to say that x minus 1 has to always be positive. The argument always has to be positive. So add 1 to both sides and you get x is greater than 1. So that means your domain is everything to the right of 1. You're allowed to plug in anything into the function that's to the right of 1. In other words, parentheses 1 to infinity. 1 to infinity. So these are parentheses here. Not square brackets, but parentheses. Okay, so we can expect that when we graph our curve, everything's going to be to the right of 1 as an x value. So we're going to have everything to the right of 1. Now let's start off with graphing the parent, and then we'll do our transformations. So the parent here would be y equals log base e of x. Now we'll have a vertical asymptote at x equals 0. That's for the parent. Not for the transformation. Not for the transformation, but for the parent. Right now we're just working on the parent, not the transformation. We'll have an x-intercept, always at 1, 0. That's for the parent. And then we'll have an additional point, if I can spell that. Additional point at a comma 1. Now what is a here? A here is the base e. So rather than writing a, we're going to write e comma 1. Now remember what e is. E is about 2.718, right? So it's between 2 and 3. It's close to 3. So keep that in mind when we're graphing. So here I'm going to graph out my my dude. My parent, I should say, not my dude, my parent. I have an x-axis, and I have a y-axis. And we have a vertical asymptote. I'll make that in purple. Vertical asymptote is here. At x equals 0, we have an x-intercept at 1, 0. And we have an additional point at e comma 1. Let's find where e is. So e is about 2.7. Let's see. 1, 2, 3, 4, 5. So e would be close to 3, but not quite. So, and comma 1, don't forget the y value is 1. That would be about right here. So imagine being close to 3 on the x, but not quite there, and then 1 on the y. So for the parent, we're going to connect those 2 points, and we're going to go off to positive infinity as we go to the right. And as we go to the left, we're going to go down to negative infinity towards the asymptote. Towards the asymptote. So these points are 1, 0, and e comma 1. 1, 0, and e comma 1. Okay, so now I got to do my transformations. Call this the transformed function. So there are going to be 2 transformations. So we have y equals log base e of x. First of all, minus 1. And then minus 2. Okay, so I'm going to do my transformations all in one step. Let's make this orange. Okay, maybe not orange, maybe a green here. I'll call it my transformed function. So basically the first thing we're going to do, we're going to shift everything. The minus 1 inside of the house tells shift everything right 1. Can I write 1? Yeah, right 1. And then we're going to shift down 2. So that means we're adding 1 to the x values and we're subtracting 2 from the y values. So if I look at my vertical asymptote here, my vertical asymptote, I'll make that in green. So your vertical asymptote involves x equals 0, right? The equation x equals 0. That's for the parent. So what you're going to do, you're going to add 1 to that. Why? Because you're shifting everything right 1. So if you shift everything right 1, that means 1 is being added to the x value. So we're going to get x equals 1. So the vertical asymptote here is going to be over at x equals 1. Okay? So that is the new vertical asymptote for our new function. The second thing, the x-intercept is going to get shifted right. So we'll just call these points. So the x-intercept, I'm going to circle that in green back here, which was 1, 0. It's going to be shifted right 1. So you're going to add 1 to the x value. You're going to have 1, okay? And then it's going to be shifted down 2, so you're going to have to subtract 2 from the y value. Did I do that right? No, I didn't do that right. So I add 1 to the x value, I get 2. Come on, right, please. Okay, so we add 1 to the x value. It was 1, it now becomes 2. And we subtract 2 from the y value, it was 0. We're subtracting 2, it's becoming negative 2. Okay, 2, negative 2. That's a point. Now my other point, which is called the additional point, we have to add 1 to the x value, so we get e plus 1, and we have to subtract 2 from the y value. It was 1, so when you take 1 minus 2, you get negative 1. So these are our 2 points. 2, negative 2, let's find where that is. 2, negative 2. So yeah, we took the 1, 0, we moved it right 1 and down 2, so it's down here. That's 2, negative 2. And then we took the other point, we moved it right 1 and down 2. So that's e plus 1. So it moved right 1 here and then down 2, right here. So that point is e plus 1 and minus 1. So we connect these two. And as you go to the right, this graph still goes off to positive infinity. But as you go to the left, the graph goes down towards the vertical asymptote. The vertical asymptote, I don't know. I'll make the vertical asymptote yellow so it doesn't get confused with the graph. So this is your graph right here. This is y equals the natural log of x minus 1 minus 2 in green. I went 2 key points, 2, negative 2,